Alright, which questions do we want to see? Do go over on the shark bite? Majority 1, 3, and 5. So we'll do those 3. If you guys think Alright, number 1. If this is direct, if I were to, well, let's backtrack. I'm going to show this in Desmos and then we'll talk about algebra. So 1 can be done in Desmos. 2, we'll figure that out, or 3, we'll figure that out, and then 5 can be done on this graph. Right, so for number 1, if I were to put these in as a table, we haven't really talked about this. We briefly talked about it when we saw it on the notes with direct, inverse, and neither. But if I'm looking at which x has a line with which y, so -2 and 1 go together. Then I see that 3 and 0 go together. 7 goes with 1, and it also goes with 4. So as I'm looking at this, it does not make a line that goes to the origin, so not direct. It makes a curve, but not the curve we want, so it's not going to be inverse. But if you divided these, 1 divided by -2, 0 divided by 3, you'd see that it's not direct. And if I multiplied, I also wouldn't get the same answer, so it is neither. Questions on that one? Number 3, write the equation of the given line. So because we're given a graph, we could find the slope of this line, which should be -2. If this line were to continue and I kept going down to the left one, I would end up at -2. So that equation would be y equals -2x minus 2. In order to do that on Desmos, you would have to pick a point that the line goes through, type in your y equals mx plus b, change it to -2, and then figure out where that y-intercept would be. So it could be done, but there's extra steps in there, rather than just doing it on the graph. 5, similarly, if I plotted these 2 points, 0, 3, and -2, 4, I could figure out what the slope is, and I already have my y-intercept, and that would give me my equation. So y equals -1/2 x plus 3. Remember that if you are doing this in Desmos, so not the last 2, but the first one, make sure you're writing did in Desmos or use Desmos or something. Let's look at the course calendar and talk about some of those important things. Alright, so take note of when your Delta Math is due. You have 2 due this Friday, 2 due next Friday, and that's it. You will be finishing this by next Fridays to be quizzing the following Tuesday and testing that Thursday after that, so in a couple weeks. This will be the last, I just realized that says Unit 8 quiz and Unit 7 test. This is Unit 8 for everything. Anyway, this will be the last quiz and test that goes on this quarter, as well as the last official quiz, grade, and I should say official quiz and then official test before the SOL. So after this, we will stop quizzing, stop testing until the SOL, and then after we'll review and test, not quiz. but I'll have quizzes available if you want to see what they would look like and practice on your own. Because we won't be quizzing anymore, some of your short right answer sheets and the SOL practices will become formatives so that you have something in the grade book. That also means this will be your last flex day until after the SOL. So if you don't get retake stuff done on this day, you'll have to come see me after school. Questions on any of that? The next calendar you get will have everything we're going to do for the rest of the year. And then we'll talk about that when you get that, but at a later one. Okay. So you all should have these notes. So this unit we're going to talk about exponents and their rules and polynomials and different things about them. I want you to go ahead and write this down. So when we talk about polynomials, we're talking about two different things. One is like this umbrella term for everything underneath it, and then one is going to be a specific definition. We'll talk about that in a moment. But for the umbrella term, it's an expression consisting of many terms. And when we talk about polynomials, we're going to write it in a specific order, in ABC order, with the highest exponent first. But something about that is a little weird, so we'll do some of those examples. When we write them with the highest exponent, that is called the degree. So we're going to be classifying polynomials by the degree, the highest exponent, and number of terms. And your job is going to be to keep those straight. You have two tables or charts underneath this. We're going to add something to one of them while we're talking about them. So then in the table, when we talk about degree, that's going to be your highest exponent. So if you don't see an exponent at all and you don't see an x, so like we just had 7, that would be a constant. If we had something with an x in it but no exponent, that's going to be linear. Something with a squared in it, that's quadratic. Something with a 3 or a cubed in it, that's cubic. If we had 4, that would be quartic. And then 5 is quintic. So you may see some quintics. So that is the degree. And then number of terms is based on how many of them are there. So if I just had 7, that would be monomial, monomial 1, so just one term. If I had 2 terms or some combination of 2 terms, that's a binomial. And then 3 terms would be a trinomial, and then 4 or more is a polynomial. Polynomial can be used multiple ways, though. So when I say classify the following polynomials, these are all polynomials, and specifically 4 terms or more are polynomials. So keep that in mind. Don't let that confuse you. So we're going to classify these by the degree and number of terms. 6 would be what degree and what number of terms. Constant and which of these? Monomial. constant because there's no x. There's no exponent. Monomial because it's just one single term. What about number 2? It is linear. And then number of terms? Monomial. So linear because of the x, and monomial, it has one term. Number 3. Linear and which one? Binomial, yes. So linear because of the x, binomial because it has 2 terms. Number 4. Quadratic trinomial, it has the exponent of 2, and there are 3 terms. Number 5. Cubic binomial. It has an exponent of 3, but there are only 2 terms. And number 6. Quartic polynomial. Has an exponent of 4, and there are 4 terms. So, just to clarify again, this is a monomial polynomial. It's the type of polynomial, but specifically it's a monomial. So when you see this, it's just talking about which type. Okay, questions about the classifying section? Okay, moving on. Now we're going to rewrite these into standard form. So standard form, ABC order, highest exponent goes first. So number 7, we're dealing with just x's and a constant. The highest exponent goes first, 2x squared. And then it goes down in decreasing exponent order. So then 3x, and then 1. And then just for practice purposes, if we were classifying this, what degree and number of terms would that be? Quadratic trinomial. Yes. I'm just going to shorten that and put that off to the side because it didn't ask for that, but it's good practice. Number 8, how would we rewrite that? Or what would go first? Right there. Cubic. It is going to be cubic, and the cubic term, the 7x to the 3rd, will go first. And then the x squared plus x squared, and then minus x, and then 64 plus 64. So we found this is cubic. What is the number of terms? Polynomial. So 4 is a polynomial, yes. Alright, let's get 9 because that would be similar. 10, what would be first?
Negative x.
Yes. And then plus x. So notice that normally the x squared would come first, but we don't have that, so don't add anything that aren't there. And then our plus 24. Degree and number of terms? Cubic trinomial. And then 11 and 12 are different because we have different variables. So with that ABC order, so we're looking for A first. A also happens to be the highest exponent, so A to the 3rd. Then you deal with everything that has A first. So the next one that has an A in decreasing exponent order is your 5a squared b squared. Then something else that still has a is your 2ab. Then once you run out of your a's, then you can go on to your b. So ABC order trumps everything else, then highest exponent. If we were to do degree of this one's a little weird because we see 3, but also because this term has a 2 and a 2, we have to combine those and make 4. So this is really the highest exponent. So that would really be a quartic polynomial. So those ones are special. What would go first in 12? Say that one more time. Negative x to the third. And then negative 7x squared y squared. And then y cubed, yep. And then our plus 13. And this one's going to be the same, the quartic polynomial. Okay. Do we have any questions on how to put polynomials in standard form or how to classify them? So one of the Delta maths that's due this Friday is everything we just did. The other one, you'll have to wait until Friday to completely do, but you'll be able to start it today. On the back of this page is a bunch of practice for this, but we're not going to do that. Go on to the next page that looks like this. So this first part is some review on things that we talked about at the beginning of the year when we were simplifying, evaluating, things like that. When we have a negative base, so negative bases raised to an even power will always be positive, but we must use parentheses. And then I'm going to give you an example here in a moment. Negative bases raised to an odd power will always be negative, no matter what. So if we had some example, let's say our negative base was negative 2, and I raised it to some even power like 2. And I'm using parentheses. Because we're using parentheses, that would be negative 2 times negative 2, which would give us a positive 4. But if we weren't using parentheses, this would be the same as saying negative 1 times 2 squared, which would give us a negative 4. So we have to use parentheses, especially in the calculator. But if we took that same base and we raised it to an odd power, let's say 3, what is that? Negative 2 to the third power. So not multiplying negative 2 times 3, but negative 2 times negative 2 times negative 2. Negative 8. And then if I didn't use parentheses, what would that give me? Not positive 8, but still negative 8. Because this is saying really the same thing, negative 1 times 2 to the third. So either way, with a negative base and an odd power, you get a negative answer. But with a even power, you have to use parentheses in order to make it positive. So that was brief review on negative bases. But now we're going to talk about negative exponents. So this is one of your rules that you'll need to remember. First, we'll talk about some positive exponents. We know that 0 squared is the same thing as 0 times 0, which is 0. And then 1 times 1 is 1. 2 2 times 2, 4, and 3 times 3. So we know those. With a negative exponent, I'm going to read this first. When you have a negative exponent, you're going to take the base to the reciprocal, so you're going to flip it. And then magic math happens. The rule states that when you flip it, the exponent goes with it and becomes positive. It just happens. So in these examples, if I were to do this rule, these are all over 1. If I were to take 0 over 1 and flip it, I now have 1 over 0, and the exponent becomes positive. But this one's a special case because we know 0 squared is 0, and 1 over 0 would be not 0.
Undefined.
Undefined. So that one's a special case. 1 to any negative power is also a special case. Because if I take this and I flip it, and I make the exponent positive, we know 1 squared is 1, and that would just be 1. So your 0 and your 1 to negative bases are special cases, so we kind of disregard those. Everything else, though, will apply to what I'm about to say. If I take this and flip it, we have 1 over 2 to the positive 2. We know 2 squared is 4. So the negative and positive exponent answers are reciprocals of each other. This was 2, this was 4, this is now 1 4. So 3 to the negative 2 would be what? 1 9. So as we get more into simplifying, you have to remember this rule. Anytime you see a negative exponent, take it, flip it, make the exponent positive, simplify it if need be. Questions on that so far? Now we're going to talk about the variables. Works the same way, it's just we don't have something to actually simplify it. We don't know what the variables represent. If I were to expand this, I know this is a times a, but that would just simplify back to a squared. So we're not going to do that for all of those. But I did want to mention something about the d to the first. Think about all the numbers you know and all the letters you know. All of those have an invisible exponent of 1 that you just don't see. It's there, you just don't see it. So when you see variables without a 1, you have to remember that it has an exponent of 1. Okay. If we were to apply this rule, apply the negative exponent rule to this, how would we rewrite this? One over a squared. This is the base. It's over 1. Take it, flip it, make the exponent positive. So then what would x to the negative 3 be? One over x to the power of 3. D to the negative 1. 1 over d. Or if you wanted to put the exponent, you could. Either or. And then y to the negative 5th. 1 over y to the 5th. Negative exponent rule. Take the base, flip it, make the exponent positive. Simplify if necessary. Questions on how the negative exponent rule works? Go on to the next page. Alright, now we're going to talk about 0 exponents. So the rule for 0 exponents is up here. When 0 is the exponent, the answer is almost always 1. I'm just going to talk about some special cases. So, in general, if we were describing how this rule works, if I were thinking about, I had 2 as some base, and I made x my exponent, and I start putting in random numbers. Well, I know anything to the first power is really itself, so 2 to the first would be 2, we know 2 squared is 4, 2 to the third is 8. In this pattern, I'm dividing each one by 2, so it would make sense that 2 to the 0 would be 1. In these other numbers, I can see that same pattern. I can see what each one is, and if I were to divide each thing by 10, I see that same thing, that 10 to the 0 is 1, negative 3 in parentheses would give me 1. But when I get to 0, 0 to any positive power is 0. So then, by default, this should be 0. You can write that off to the side. You can put that, but it's going to get erased. But I'm going to also show you why that's not. So, in general, this is the rule, that anything to the 0 power should be 1. And if that's supposed to be 1, but also 0, it can't be both. So, in your calculator, put 0 to the 0 power. What happens? You get an error. It doesn't work because it's trying to be 1 and 0 at the same time and it can't be both. So it's undefined. So 0 to the 0 is a special case. That one is undefined. The other special case is if you have a negative base raised to the 0 power and you don't have parentheses. So here we had a negative base, we had parentheses, it was positive. But if I had negative 3 to the 0 without parentheses, that would give me a negative 1. I want you to write this down. Negative bases raised to the 0 power, if parentheses aren't used, equal negative 1. And those are your two special cases. If it has a negative base and you're not using parentheses, negative 1. If it's 0 to the 0 power, it's undefined. Other than that, everything else should be 1. So if I said, what is 100 to the 0 power? What would that answer be? 1. If I said 1,000,000 to the 0 power? 1. If I said negative 1,000,000 in parentheses to the 0 power? 1. Now if I said that without parentheses, negative 1. Once you finish this, go on to the next page. So we're going to do some of these examples, and then you'll have some time to practice, and then we'll come back and talk about some other things. So if I had 1.02 to the 0 power, that would give me 1. Negative 2 in parentheses to the 0 power, also 1. If you want to rewrite your rule from the previous, I'll write that here, but it's also on the previous page. Anything to the 0 power is 1. But I'm going to put like an asterisk, a side note, a C side note about negative bases. Okay, so then we're going to do some negative exponent things that don't just have one variable or one number. Start with number 1. First, you have to think about this as these are all separate things. The 4 does not have the exponent. The y does not have the exponent, only the x. So this is the same thing as saying 4 times y times x to the negative third. And then when you see that separated, you're looking for what can be simplified or what can be changed using my exponent rules. So the 4 and the y, nothing would change with those. But the x to the negative 3, I can use the negative exponent rule. How would we rewrite that? Think about what we were just doing with our negative exponents.
1 over x cubed.
Yes. I'm going to rewrite this 4 times y times 1 over x cubed. But the end goal is we want this all condensed. So once you get the hang of this, you're not even going to be doing all of this work. You're just going to go straight into it. But for now, we want this to be condensed, so you can either go ahead and condense it all, or if you need to see how that would look, all of these are fractions with 1 underneath. Multiply across. And at the end, you should have everything put back together, no more dots. So 4y over x to the third would be that final answer there. Questions about that one? We're going to do another one, and then any you guys want to see, do go over before you have some time to practice, and then we'll come back. So number 3, we have a negative exponent, but it's in the denominator. You have to think about this like the base for this is 1 over w. So if I were to take that and flip it, I'd have w with a positive 4 over 1, which would just be w to the 4th. As you get the hang of this, you'll start to see or just be able to do that if you have a negative exponent in what would be the numerator, it's going to get moved to the bottom, so you can just move it. If you have a negative exponent in the denominator, it's going to get moved to the numerator. They're just going to switch places. Questions on that? Look at these other ones, 2, 4, 5, 6. Any of those we want to see, do go over, have questions about. 2, 4, 3, 6. 5. Alright, so 4, same thing as number 1. I'm going to kind of separate these. 7 squared times s to the negative 4th times t squared. Of those 3 things, 7 squared, I can figure out what that actually is. S to the negative 4th is going to get changed. T squared is going to be by itself. It's not going to change. So 7 squared is going to be what? 49. How would we rewrite s to the negative 4th? One over s to the 4th. T squared stays the same. And then if I were to condense that, remember that the 49 to t squared there over 1. So those are going to be what's in the numerator. S to the 4th is going to stay in the denominator. So 49t squared all over s to the 4th. Questions about that one before we do 5? I'm going to try to separate less so that we kind of see how this progresses and we can show less work. So of these things, I know 2 to the 5th can be figured out. We can figure out what that is. C is not going to change. A to the negative 3 is in the denominator. It has a negative exponent. It's going to get moved. B is not going to change. So let's figure out what 2 to the 5th is first. 32. So I have 32c over a to the negative 3 times b. A to the negative 3 is going to move up. So I'm just going to replace or move it up because it would flip. And I have to put this in ABC order. So 32a to the 3rd c over b. Once you get the hang of this, all of that can really be done in one shot. But we're still learning, so I'm separating. Questions about that one? Right, we're going to kind of condense and do a little bit more simplified here. So in number 6, we have a couple different things. We can figure out what 4 to the third is. We have 3 negative exponents. So all of those are going to switch places. So we're going to do that at the same time. What is 4 to the third? 64. X to the third. I'm going to switch the 3 to the negative 2, z to the negative 6 up, and move the y's to the negative 2 down. So we've switched places. Now we can figure out what 3 squared is. And I'm going to move that next to 64. What is 3 squared? 9. And then our last step would be to actually multiply 64 and 9. Will someone do that? 76, x to the third, z to the 6, all over y squared. What questions do we have on that? If you want to rewrite the negative exponent rule from the first page, you can. I'm not going to write that there. I want to give you some time to practice, and then we'll come back and talk about those, and then we'll briefly start the next thing, and then we'll be done for today. So on this next page, I'm going to give you, it's about 20 right now, yeah. So until about 35. To do as many of these problems as possible. Get through at least 15, but you should be trying to get to these bottom ones too. If you finish this, move on to the next page. I'll be walking around if you have questions. You guys can work together on it. You have about 15 minutes to work through this. We'll come back, go over any questions you have, and then start the next. Which ones do you want to see you go over and have questions about? All right.
37.
Any others? 36. 46. 46. Right. No, 36. Okay.
15.
Any others? All right.
47. 49.
Alright, we'll do those. If we have any others, we can see those. So starting with 15. Alright, so for 15, both of these have a negative exponent. So you're going to switch the placement of both. If you put the exponent, that's fine. You don't need it. And then you're going to simplify. So this would be 1/4. If you had put this into your calculator and put in 32 to the negative first over 8 to the negative first, it would also give you that same answer. Now, this won't always work for everything, but for now, you can use it. Questions on 15? Okay, 37 is just your negative exponent rule. Take this, flip it, and make it positive. 46. There are a couple of negative exponents, so those are going to get flipped to the denominator. The positive exponents and 8 stays in the numerator. So that would be 8b squared over a to the third c squared. Now, this is like the shortest, not showing any work. If you wanted to separate it, change the two, flip them, and then condense them, you are more than welcome to do that. Questions there? (47), the s to the negative 9th and the t to the negative 1st get brought down. So it would be 15 over s to the 9th, t to the 1st, or you could just leave it as t. In 49, d and e switch places. So this would be e to the 7th over d to the 4th. Were there any others we wanted to see, do, go over, have questions about? So in 51, m and p are going to switch places. 6 and n stay put. So we're going to have 6n p, you can put to the 1st, you don't need it, over m to the 8th. Look at the new packet I gave you. We're going to do, on the first page, a couple of these. I want you to try and figure out the rule. If you already know it, hold off on saying anything. Because I'm going to show you how to expand it, but we want to figure out the rule so that we can stop doing it. So if I were to expand this, I have x squared is x times x. X to the 4th is x times x times x times x. And if I counted the total number of x's, we have 6. If in number 2 I did the same thing and I separated each thing, each term, I have 4 times a times 4 times 3a's. I'm going to rearrange it so that the 4's are together and the a's are together. And I can say that I have 2 4's and 4 a's. And 4 squared is 16. So I'm trying to figure out, like, how could I look at this, think of some rule, and get this without doing this part? See? So, not subtract in this case, subtract later, but specifically add yes. If I look at the two exponents of the same base and add them, I will get this, so I know how to do this. Now, you could still do this, but I will say we're going to get really big exponents eventually, and you're going to want to stop doing that. Same thing here. If I added the exponents, and I have to remember that anything that doesn't have an exponent has an exponent of 1. If I added the exponents of 4 and added the exponents of a, I would get this answer. So that is the rule. So I'll write down the rule, and then we'll go over any others you guys want to see. Do go over, and then we'll be done. So when multiplying like bases, you add the exponents. So of the remaining 4, are there any we want to see, do, go over, have questions about? So we're going to use this rule instead of expanding, but again, if you would like to still expand, you're more than welcome to do that. when multiplying like bases, add the exponent. So I see that we have common x's, like bases of x's, like bases of z's, and we have a random y. Then we have these three numbers that have nothing to do with each other. So we don't have like base numbers, but we can still multiply them. I'm going to rearrange. 5 times 2 times 3. Anything that doesn't have an exponent, I'm going to put a 1. And you don't have to do this. I'm just doing this to show you how it works. But eventually you should be able to just add them and put it together. So I have x to the first plus 8, y to the fourth, z to the second plus 1. And then I'm going to simplify and condense. So go ahead and multiply 5 times 2 times 3. X to the ninth, y to the fourth, z to the third. Now again, you could have skipped this step and went from here to here. But if you need to do this, that is also okay. Other questions on this page? We have like bases with 2's and with y's. The x is going to stay the same. The 7 is going to get multiplied. So I have 2. These both have exponents of 1. So it's going to be 2 squared times 7. The x squared stays the same. And in this case, because we have a negative exponent, we're going to subtract or add a negative instead of add. So 3 minus 7 will give us y to the negative 4. So we know this is 4. 4 times 7 is 28. And we know that this exponent is negative. It's going to get moved to the denominator. So 28x squared over y to the 4th. Or if you wanted to change this to 1 over y to the 4th and then keep going, you could do that. Questions on that one? Yes.
Can I write it the same as number 5?
Say that one more time.
Can I write it the same as number 5?
Like this?
Yes.
Yes. As long as your simplified answer looks like one of these. Alright, so then for the rest of class, you can use it to practice. If you wanted to start the simplifying exponents, the negative exponents part of that, you could definitely do that. The other ones, you don't know the other rules yet, except for this one, so you know 3 out of 5 rules. And we'll be talking about the other 2 next class. But you could start it if you so choose, do the other delta math, or keep working in either of these practices, and then I'll have you guys put your calculators at the end of it.